Hello everyone, welcome to Tech with Machines. Today is day 3 of solving data structure and algorithm problems, and we are going to solve a very common problem of an array called majority element. Majority element is generally an element which can occur more than n by 2 times of the array, and n is nothing but the length of an array, the number of elements in the array. So whatever is existing more than n by 2 is going to be a majority element. As per this question, there is always a guarantee that at least one element will be majority. Like there are two examples given here. As you can see, I have an array of 3 elements and I have 2 and 3 as the part of this array, and 3 is occurring twice and 2 is occurring once. So 3 is the majority element here because 3 occurs more than the half of the length of the array. Same in the example 2, 2 is occurring 4 times, whereas 1 is occurring 3 times, and I have 7 elements in this array, so which means 2 is occurring more than half of the element of the array, half of the length of the array, sorry. So if we go with a very basic approach, because it's an array problem and generally you have different patterns which you apply to an array problem, maybe you can sort, or you can find use an extra space in an array, or you can use a 2-pointer technique. So here using an extra space seems very simple, as I have given here that I have counted 2 and then I have counted 1, and we can save it in a dictionary or a hash map, and then iterate over that hash map and see which element is actually occurring more than n by 2, right? But in this case, the time complexity is linear, but the space complexity is also there, so that also becomes linear. So we have time complexity of order of n and space complexity of order of n, right? So if you remember our day 2's problem, that was more about buy and sell stock, and we were saving 2 variables, or we were saving a variable called maximum profit, where we kept on updating it as and when we encountered a new max profit. Similarly, what we will do here is we will have a variable, let's call it majority element. I'm gonna just do a dry run quickly here. Let's do it with example 1 first. Let's call it majority, and maybe we'll call it as 0, right? And we will have also a counter, because initially we don't know anything about the majority, so we are going to keep it 0 at this moment of time, right? Now when we start the iteration, that means the iteration starting in index position 0 will be what? So let's try to check that. Now in this case, the element at the position 2, we are going to compare it whether it is equivalent to the majority element we have encountered. If it is equivalent, we are going to increment the counter. If it is not, then we are going to decrement the counter. So that is going to be very simple and straightforward. So in this case it is not, so we are going to decrement the counter. So counter becomes -1 because the element at index position 0 is not equivalent to the majority element, right? Also, if the counter is equal to 0, then our first element becomes the majority element, right? So in this case, so before this we do increment or decrement, we are going to first check whether it is already 0. If it's 0, then we have to reset the majority element, right? So in this case, the counter is 0, so majority becomes the first element in the array, which is nothing but 3 in the example 1. And the counter in this scenario then will become 1, because now the majority is updated to the same element as the position 0, right? Now in this case, this is our iteration 0 now, which means iteration at index position 0. Then iteration at index position 1 would be that majority will become, in this case the majority will still remain 3, because the counter has not become 0 actually. So majority is going to remain 3, but our counter is going to decrement because we no longer have the current element equivalent to the majority. So the counter is going to become 0 in this case, right? So counter becomes 0. Now an iteration 2, which is the last iteration, right? Because it's a last element or last position in an array. In this case, the majority becomes becomes the element at the position 2, because in this case counter is 0, so we'll update the majority. So majority will become the element at position 2, right? Similarly, if we go through in this same case for the example 2, at iteration 0, the majority will become 2 because the counter is 0 initially. So the majority is going to become 2 and the counter is going to become 1. At iteration 1, the majority is going to still remain 2 and the counter is going to be incremented to 2. Then at iteration 2, counter is not 0 and majority is not equivalent to the existing element. So the counter remains 2, but majority remains 2, but counter decrements. So counter becomes 1 in this case, right? Now, similarly, we go to the next iteration, which will be the iteration 3. Now, in this case, the counter is still there. So majority will continue to remain 2, but the counter will become 0 because it is not equivalent to the element at index position 3. Now, after this, in iteration 4, which is index position 4, my majority is going to become 1 because now the counter is 0. So majority is going to become 1 and counter is going to become 1 because majority and the element at that position matches. Now at iteration 5, that means the index position 5, majority is going to remain in this case 1, but counter is going to become 0 because now the element doesn't really match the existing index, right? Because it is 2. Now at iteration 6, which is the last iteration, in this case, because counter has become 0, right, we will update or reset the majority, correct? Now in this case, what will happen is majority will become basically the last element at the last index position, which is going to become 2, and counter is going to become 1. So we are left with 2, and that is what is our answer, right? So this is how we are going to solve a majority element problem. It is actually an algorithm called voting algorithm. It's a voting algorithm where you are actually incrementing or updating two variables, counter and the majority, as and when you either encounter again the same element, you increment it, or if you don't encounter the same element and counter is not 0, you decrement it, and once the counter becomes 0, you reset it. So this is one of the popular voting algorithms if you want to remember, but again you are using variables here which are constant space. The time complexity is linear and the space complexity is order of 1 constant. Now let's dive into the code which I have written already. So I have already written the code here. So I have gone with the name, with the class concept, and I have given it a name majority element, and I have initialized it with a numbers array. Right? If I run it, in this case particularly, the majority element is 2, so it should print me 2. And if I just change it and bring here 2 more times, and it should basically return me 3 in this case, right? So if you can see here, what I have done is I have basically ensured that there are two variables, one being counter, which has been initialized to 0, and other being majority element, again which is being initialized to 0, right? And now we are iterating over the array, and we are checking whether the element is equivalent to the majority element. If it is, then we are incrementing the counter, otherwise we are decrementing the counter, with the condition that the counter should not be 0. If counter is 0, then we are basically resetting it to the element which we have just discovered. Finally, whatever is the element at the end which we are left with is going to be the majority element, by assuming that that will always remain there with the positive count, because it exists more than half of the length of the array. So as discussed earlier as well, that this problem gets solved in a linear space complexity and the time complexity. I hope you liked the video, and if you did, please remember to give a thumbs up or subscribe to the video as you wish.